Hello and welcome to another exciting pre-calc math video. We're going to continue section 2-5. This is day 3. And we're going to start with factoring a polynomial. And the book says the linear factorization theorem states we can write any nth degree polynomial as a product of n linear factors. So, there might be a constant out here, a sub n, but we're going to have x to the first plus or minus a number, x to the first plus or minus a number, x to the first plus or minus a number, dot, dot, dot. We're going to do that n times. Whatever our highest exponent is, that's how many of these linear factors we can break it down into. This result includes the possibility that some of the values of c are imaginary. The theorem below states that we can write f of x, our function, as the product of linear and quadratic factors with real coefficients. For a proof of this theorem, blah, 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 page 194. In the box, the factors of a polynomial. Every polynomial of degree n greater than 0, as long as our exponent's positive, with real coefficients can be written as the product of linear and quadratic factors. The linear are going to be x to the first. The quadratic, you'll have maybe an x squared in there. And they're all going to have real coefficients. Where the quadratic factors will have no real zeros themselves. A quadratic factor with no real zeros is prime or irreducible over the real numbers. Note that this is not the same as being irreducible over the rationals. For example, this x squared plus 1, we would factor that into an x plus I and an x minus I. That would be irreducible over the real numbers because we got that imaginary component in there. On the other hand, this quadratic, x squared minus 2, we could factor that into an x plus and an x minus a root of 2, is irreducible over the rationals but reducible over the reals. Don't worry about that stuff on any test or quiz coming up. So here, example 8, find all the zeros of this. It's x to the fourth, so we should have 4 zeros. And they did give us one of them. Here is 1 plus 3i. Well, I'm going to do this with a bracket. If 1, oops, get back there. So we could, let me write it like this. So they gave us a 0, so we could write, we know that x is equal to 1 plus 3i. And remember, come on, there it is. These also come in pairs. If 1 plus 3i is a solution, then there's got to be another one of 1 minus 3i. All right, so let's turn these into factors. We want to move everything over here with this x. Let me switch back to black ink. Here's x. I'm going to bring over the 1 where it becomes a minus 1. And I'm going to bring over the 3i where it becomes a minus 3i. So this, we turned that solution into a factor. Let's do the same thing with the one in red here. So we'll keep x on the left. We'll bring over the 1. It's a minus 1. We'll bring over the 3i, where on the other side it is a plus 3i. Now, what we should be able to do is FOIL this out, and that result we can divide out of our original function. We know if this is a 0 and this is a 0, we turn them into factors. We should be able to FOIL this out and divide and reduce this from a 4th power down to a squared. Now, foiling this out looks intimidating, but look what happens if we sort of group this x minus 1 here and this x minus 1 here. It's the same terms, an x minus 1 and a 3i, but we got a plus and a minus in between those terms. So when we FOIL this out, our middle terms will cancel. So this is a slick, easy way to FOIL this out. We're going to do first times first. That's going to be x minus 1 times itself, x minus 1. And then the other terms are a minus 3i times a plus 3i. That will be a minus 9i squared. Okay, so let's do a little work on this and make it look a little nicer. Well, here, this I squared, remember I squared turns into a negative 1, and that negative 1 is going to switch this sign here. So we can change that to a plus 9 at the end. Plus 9. All right, let's FOIL this out. X minus 1 times x minus 1. First times first is x squared. The outers will be a minus x. The inners will also be a minus x. And the last term, negative 1 times negative 1 is plus 1. And don't forget this plus 9 is also going to come along for the ride. And if we combine like terms here, the x squared is going to stay as it is. We got two of these minus, so that's a minus 2x. And then 1 plus 9 is plus 10. Okay, so this is also going to be a factor of our original f of x. So what we're going to do is divide this into the original problem and see what we're left with. So actually, let me get rid of these parentheses. Those are just going to bug me. And we're going to divide this into x to the fourth minus 3x cubed. Oop, that's a cube. Plus 6x squared plus 2x minus 60. Now, if we've done everything right and this is correct, we should expect to see a zero remainder. Okay, I got three terms to get rid of. I want to get rid of this x to the fourth, so I am going to want an x to the fourth right under it. I'm multiplying an x squared, so what times x squared is x to the fourth? That's got to be x squared. And now we distribute x squared to this x squared, and then to the 2x, and then to the 10. So we distribute x to the fourth minus 2x cubed plus 10x. Oops, squared. And remember, we can either subtract here or distribute a negative and add. If I distribute a negative in blue ink, this is going to change to a plus, and this here will change to a minus, and now we can just add the columns. X to the fourth is gone, and that looks like a negative 1x cubed. And there we'll have, what, a negative 4x squared. And let's bring down the next term, a plus 2x. All right, next thing to get rid of is this negative x cubed, so we want a negative x cubed right under it. What do we multiply by x squared to get negative x cubed? Minus x. And we distribute negative x cubed plus 2x squared minus 10x. And I'm running out of room, so let me do this. Oop, I think I lost my picture up there. Yeah, dang it. Let's see. Distribute a negative and add, so this will change to a plus. This here will be a minus. Last term is a plus. And if we add the columns, we get 0. Would that be a negative 2? Oh, no, those are both minuses. Oops. So that is a minus 6x squared plus 12x. Bring down the last number, that minus 60. And it looks like we might be in good shape here. We want to get rid of this negative 6x squared by having a negative 6x squared under it. And we're multiplying by this x squared, so we need a minus 6. Distribute, we get our minus 6x squared. We get a plus 12x, and we get a minus 60. That is an exact image of what's right above it. So if we subtract or distribute a negative and add, there will be a 0 remainder. So rid of this. There we are. So this is what we created by using the clue they gave us, that x squared plus or minus 2x plus 10. And if I bring this down right next to it, let's see if we can go a little farther. All right, we know this won't factor down any farther without imaginaries. So this is going to stay as a quadratic. But this we should factor a little farther. X squared comes from x times x. And the two numbers that multiply to negative 6, 1 and 6 or 2 and 3, you know, one's positive, one's negative. To get a negative 1 in the middle has to be a minus 3 and a plus 2. Now the directions did say find all of the zeros. Well, let's see. They started us with a 0, 1 plus 3i. We found another 0 because those ones come in pairs, 1 minus 3i. Now, if we set this one equal to 0, we'll get x is 3. And this one equal to 0, we'll get x is negative 2. So the directions were, again, find all the zeros, and we got them. Okay, I see a technology thing down here. Another way to find real zeros is the function example 8. Use a graphing utility, graph the function. And then we could, use the cursor, get it right over there, and get an idea what that x-intercept is going to be. Oh, now what's this? In that example, if you don't know the 1 plus 3i is a 0, it's still possible to find all the zeros. We would first use synthetic division to find that negative 2 and 3. And then once we factored out the negative 2 and 3 here, we would be left with this. And the only way to solve that would be with the quadratic formula or with complete the square. And we'll run into imaginaries because we'll have negatives under our radicals. Now it says here coming up in example 9, we'll find all the zeros, including the imaginary zeros of a 5th degree polynomial equation. But first, try this huddle problem here. Pause the video and see if you can get this one. It's very similar to what we just did, but it's a little easier. This 4i is one of your zeros, so of course negative 4i is also going to be a 0. Turn those into factors and FOIL them out, and then you will divide those into this. So pause the video and give that a try. Okay, so we know that we have a solution, x equals 4i, and we also know they come in pairs, x equals negative 4i. So let's turn those into factors. Here I will subtract 4i from both sides. Now it's a factor. Here we're going to add 4i to get a factor. And if we FOIL these out, it's a sum and a difference, so the middle terms will cancel. First times first is x squared. Negative 4i times positive 4i is negative 16i squared. And the I squared, remember, will turn into a negative 1 that's going to flip this sign. So we have an x squared plus 16 is one of our factors. Now we want to divide that into this. So let's see, we got 3x cubed minus 2x squared plus 48x minus 32. And we're going to divide into that. Let me move this over here. X squared plus 16. Now I'm not going to put a 0x placeholder in here, and it shouldn't be that big of a deal as long as we line up our other stuff correctly. So we want to get rid of this 3x cubed. So we want to multiply and get a 3x cubed right under it. That's a cube. And we've got an x squared to multiply by. So we're going to need a 3, and we're going to need an x. And I'm going to put that right over this 48x. So 3x times x squared is our 3x cubed, and then we have 3x times 16, that's 48x. And I'm putting that right under the other 48x. I could have put a placeholder in here, a 0x to the first, and I would have multiplied and had a 0x squared here. So let's see. We subtract or distribute a negative and add. If I distribute a negative, these will both be minus, and then when I add them up, we'll get nothing here and nothing here, but we do have a negative 2x squared from this term, and we'll bring down the minus 32. Oh, this is looking perfect. So I want to get rid of this negative 2x squared. I want a negative 2x squared right under it. So what do I multiply this x squared by? It's got to be a negative 2. So we get the negative 2x squared we need and a minus 32, and that is just perfect. If I distribute a negative and add, we get zeros. So there is no remainder. Our factor did work out nicely. So we had the x squared plus 16, and then we found this 3x minus 2. All right, the directions again did say find all the zeros. So we'll start with the one they gave us, 4i. We figured out the negative 4i because they only come in pairs. And after we divide it out, we're left with this factor, 3x minus 2. If we set 3x minus 2 equal to 0, we're going to add 2, 3x equals 2, and divide by 3. X is 2/3. So that would be our last 0. It is a third power function, so we got 3 zeros. Okay, let's try that fifth power one. That sounds like fun. Find all the zeros. Write this as a product of linear factors, and then also list out all the zeros. So let's get started. So first, let's make a list of all our possible suspects. I do like the leading coefficient is a 1. That'll make it a little easier. Our constant at the end is 8, so we need all the factors of 8. Plus and minus 1, plus and minus 8. 1 times 8 is 8. We can do 2 times 4 is 8. 3 doesn't work, and when we get to 4, we're just reversing the 2 and the 4 we had earlier. So it looks like we have 8 possible suspects. So let's see, I guess we just start synthetically dividing until we find one that works. So let's look at our variables here. It looks like we're missing x to the fourth, and we've got cubed and squared in first power. So when our synthetic division is set up, we're going to need a 1, a 0 for the x to the fourth, 1x cubed, 2x squared, minus 12x, and a plus 8. Now, where do we begin? We've got 8 to choose from. I usually start with positive 1. It's a nice, easy number to multiply by, and a lot of times it does work. If I bring down my first number 1, 1 times 1 is 1, and we add the column. 1 times 1 is 1, we add the column. 1 times 2 is 2, and that adds up to 4. 1 times 4 is 4, and negative 8, it looks like we got it. So the 1 times the negative 8 is negative 8, and there's our 0 remainder. So let's see, we used 1 there. So one of our solutions is x equals 1. And if we turn that into a factor, it's going to be x minus 1 as a factor. Now, we can just synthetically divide our next number right into here. You know, because we started with fifth, so this would be a 1x to the fourth. Let's do another one and see if we can get it reduced down another power. So we tried 1. Hey, let's try negative 1. So I'm going to switch to black ink, and I'm going to put a negative 1 out here. And let's see, I'll drop down my leading 1. Negative 1 times 1 is minus 1, and we add up to a 0. Negative 1 times that 0 is 0. Add it to the 2, and you get 2. Negative 1 times 2, negative 2. That adds to a 2. Negative 1 times that 2 is negative 2. And that adds up to a negative 10. Ooh, what happened? Well, we did get a remainder, so what happened is negative 1 is not a factor. So I'm just going to erase this. There we go. Well, let's try negative 2. Turn that to a 2. And we bring down this 1. Negative 2 times 1 is negative 2. And that adds up to a negative 1. We multiply that by a negative 2 and we get positive 2. That adds up to 4. Negative 2 times 4, that's a negative 8. Negative 8 plus 4 is negative 4. Oh, here we go. Negative 2 times negative 4 is positive 8. Remainder of 0. So back up here to my list, we've got x equals negative 2 is a solution. And if we turn that into a factor, x plus 2 would equal 0. So there's our factor. Now these numbers at the bottom are the coefficients of our new polynomial. Let me get rid of this. There we go. So we started with fifth power. Oops. We started with fifth power. We factored out one that would take us down to fourth, another one that would take us down to third. One to take us down to fourth. This one took us down to third power. So this one is an x to the third, and then minus 1x squared. And then we've got a plus 4x and a minus 4. Can we factor that? When I look at the 4's and the 4's, it looks like we can factor by groups. If I group the first two, we can pull out an x squared, leaving an x minus 1. The next ones here, I'll group those off in blue. It's a factor out of 4. Plus, put a 4 there. Left in the parenthesis, x minus 1. Okay, looks like we're in good shape. So if I put a set of brackets around that, I can underline here the x minus 1 factor. That gets factored outside of the brackets. And then what's left inside will be the leftovers, an x squared and a plus 4. X squared plus 4. There we go. So here's a factor. We've already had that one, but remember we can have repeaters. So there is, I'm just going to list it here just to show all of them. So here's another x minus 1 factor. So we do have an x equals 1, another solution. And now we're left with this x squared plus, where was that? X squared plus 4. And that is going to lead us to our last two solutions. Remember, it's fifth power. We should have 5. We've already got 3, including the repeater. But if I set this x squared plus 4 equal to 0, I'll subtract 4. X squared equals negative 4. And when we take the square root of each side, remember we'll always have our plus and minus, positive and negative. The square root of 4 is 2, and the negative will come out as imaginary. So plus and minus 2i. So back over here to our list of solutions, we have x equals 2i and x equals negative 2i, because they do always come in pairs. And to turn those into factors, we would make that an x minus 2i and an x plus 2i. Come on, there it is. Let's see, the directions again, write this as a product of linear factors. So I guess to really make it a product of linear factors, we would sort of have these all written out. We're going to have an x minus 1 for the first factor. To account for this one, let's just square it. And then we've got an x plus 2 factor. Let's put that in there. And then an x minus 2i and an x plus 2i. So there they are written as a product of linear factors. Again, linear factors because all these x's are first power. And I guess they got a picture up here. Let's see what their picture looks like. And our real solutions are on here. What do we got? Positive 1, we bounce because of our even multiplicity. We cross here at negative 2. And our imaginaries, of course, are not x-intercepts. All right, here's one for you to try. This one, it's x to the 4th. When you do synthetic division, make sure you account for the missing powers of x. And let me see my notes on this one. When you're trying synthetic division, like I always try 1 and negative 1 first. So give those a try and get the 4th power knocked down to a squared, or maybe even if it's cubed, you could do a factor by groups. So you know the routine. Pause the video and give it a try. All right, so our possibilities, leading coefficient is 1, so we can ignore the denominator. Our number at the end is 9, so the factors of 9 are 1 times 9 is 9, or 3 times 3, plus or minus 3. So it looks like those are our only possibilities. So again, I always like to try 1. Let's see what happens. Coefficients for synthetic division. 1, 0, 8, 0, negative 9. We bring down 1. 1 times 1 is 1. And we add. 1 times 1 is still 1. And we add. 1 times 9 is 9. Add those up. 1 times 9, 9. 0 remainder. Okay. Now there's two alternate rates we could take on this. We had x to the 4th, so this is now 1x cubed plus x squared plus 9x plus 9. If you want, you could stop here and factor that by groups. That would work. Or another way would be to continue with the synthetic division. So I'm going to switch to red ink. Let's try a negative 1. Bring down my 1 and multiply and add and multiply and add and multiply and add. There it is. We got another solution. So 1 worked, negative 1 worked. Let me start a little list over here. So x equals 1, x equals negative 1, and now what we're left with is 1x squared plus 9, x squared plus 9. So after our division, we got an x squared plus 9. Now, it's not going to factor, but we can set it equal to 0. And we're going to subtract 9 from each side. And then when we take the square root, x equals, we'll have our positive and negative. Square root of 9 is 3. negative comes out as imaginary piece. So back to our list, x equals 3i, and x equals negative 3i. Ooh, that's a pretty, there we go, x equals, that's a little better. So again, if we want to make it exactly as the directions say, the product of linear factors, we would turn these solutions into factors. So let's move the 1 over. That'll be an x minus 1 factor. Let's add this 1 over here, so that'll be an x plus 1 factor. Subtract the 3i, you get an x minus 3i. And for the last one, add the 3i, x plus 3i, because they always come in pairs. So if we did FOIL that all out, we should get back to our original equation. Okay, I hope you enjoyed the video as much as I did. Look for the assignment on WebAssign, and we will probably be doing those odd problems the next time I see you in class.